Hello everyone, this is a quick video on typecasting. Casting is used when different numbers with different data types are used together. Before explaining how this works, let's see what the different data types are. Notice that they all have different sizes and they have different types. Most are numeric, however one is a char and one is a boolean. So for the integer data types, they can range from 8-bit to 64-bit. These are integer data types, meaning that they are whole numbers. They don't have decimal places. And here are floating point data types, or decimals. There are two types, float and double. Double is a data type that is twice the size of the float data type. Float is a 32-bit, while double is 64-bit. Double can hold more decimal places and larger numbers than a float can. Here we have some examples of casting to other variables. Notice that without cast, we get an error called a type mismatch, as seen here, saying that it can't convert from a double to an int. And if we go and click here, it's saying the problem is on line 12. Line 12, we're trying to put a double inside an int, so we just put an int. So it will go and remove the decimal place and just return the 5. And you'll see when we run it, it outputs 5. So we end up losing this information. And notice that you can do it with all these other numbers. You can also put letters to indicate data types. So we're indicating that this is a double. We're indicating that this is a long. And you can also put an F after it to indicate that's a float. However, Java defaults to doubles when you do decimal places, so you'll almost never see a D put after it. You'll see an F to indicate that's a smaller decimal, and you'll need to have an L indicating that it's supposed to be a larger integer. So the reason you might want to do this is if, for example, you have an int, you want to put it into a short, which is a smaller integer data type. The reason you might want to do this is if, for example, you want to put an int into a short, which is a smaller integer data type. The problem is that an int is a larger size than a short, so there is going to be information loss. Also notice that an int is 32-bit and a short is 16-bit, so it should be pretty obvious that you'll need to cut out something in order for one to fit into the other. So this can be fixed with casting. However, depending on what you are casting, you might have information loss. Notice here the original number gets changed. So you need to use a function to remove and restructure the information. Another example of casting is casting a double into an int, or more generally casting a floating point value into an integer value. This is an especially common form of casting. Typically, putting an int into a double is usually fine, since nothing needs to be deleted. A bunch of zeros and a decimal or a floating point simply gets added, for example, to the 143. So you'll notice that 143 stays the same value throughout this. However, if we're casting a double to an int, there will be some kind of information loss. Notice here that 654.3454344 gets changed. Notice that 654.3454344 doesn't fully fit into the integer data type, since it can only hold whole numbers. So we need to go and cast this. Notice that the value is now less than the original value, since it is only 654. You have lost accuracy. This truncation happens for other data types also. Commonly, if a data type is larger and or stores a different types of information, you need to cast to convert it. But also note that putting smaller data types into the larger ones usually is fine. For the integer data types, a short can go into an int can go into a long, a float can go into a double. Also note that you can cast inside of math equations. So for example, when calculating an equation and converting to a long, you can turn chars into their numeric equivalent, you can turn a double into a short, and you can convert a float into an int. And then when they are all added together, they're all converted into long. Which this conversion technically isn't necessary. You could just put them directly into the long variable. However, if one of these happen to be converting to a double, then you always want to at least guarantee that's going to be the right data type. So note here that when we run it, we're going to get the type mismatch. It's saying it can't convert from a double to an int, which we have a double, and we're trying to convert to an int. So we need to go and cast this to an int, and you'll see that works. However, notice that even though we cast j is still going to stay this value. So casting does not change the value of the variable, unless we decided to do k equals j, or something like that, which k is an int, so all that happens is a bunch of zeros get added onto the 9, like here. So then we lose it. So the value will only change once there's an assignment. So without it, casting won't change the value. On a final note, this casting is a major issue, especially when doing division. If you do not put a 0.0 after a number, it is assumed to be an integer, which means that it can only be a whole number. So if you divide 5 by 6, you end up with 0. This can be fixed by simply putting 0.0 after at least one of the numbers, indicating that it is a double, or casting one of them. And just for your benefit, here is another example showing when and when you cannot cast a data type to another data type. So that is typecasting. Let me know if I missed anything. Thank you.